Rachel and I are very happy to be here. Here's what we hope to cover in the next 60 minutes or so. Rachel's going to start by giving you a little bit of background on digital twin and specifically what we focus on, which is digital twin of an organization, a DTO. And then we'll talk about some of the key components for digital twin. Obviously, software is a major component of that, having technology. So we'll talk about technology, and I'll be showing you one Canadian technology that we've used quite a bit in the last few years, and we'll do through a use study actually with a company called Crosby's Foods. If you're familiar with Crosby's molasses, if you're any bakers in the room, you'd probably recognize that. So we'll talk about their implementation of DTO, and then we'll summarize this. So we'll hopefully leave some time for Q&A, but certainly if there's questions along the way, feel free to interject. This is just basically our backgrounds, but I'll give Regis full credit. We met about, what, 2.5, 3 years ago, was it back then? Yeah, and so we got together over probably a beer. So I filled him in what we were doing at Landmark, and he says, you're doing a DTO, he says. And I said, what's a DTO? So I'll give full credit to Regis for exposing us to what digital twins were all about and how we played in our practice and the tools that we were using in that field and things like that. So I'll be your clicker for the next few slides. Okay.
We'll speak about Gartner, and why Gartner? Because it's a company doing insight and expert guidance for a lot of companies, and especially IT companies. So you will see our definition of DT and DTO, it's referring to Gartner. So that's very important for us to present you Gartner, but it's not the only one. You have also research and advisory companies like AI and Multiply and Quadrant Knowledge Solution. And we'll present you later a slide showing what exactly Quadrant. Speaking of Gartner gave a definition of a digital twin, which is quite simple to understand. So it's a twin between something real and something virtual. So it's a digital representation of something which is real. So it could be, so it's a software. At the end, it's a software, it's a model, but you can model any kind of object, process, organization, even person, or any kind of abstraction. But for us, it's more things, process, and organization. And of course, we need data to do that. Gartner proposed 4 types of digital twins. The first one is quite well known, DT based on Internet of Things. I'm sure that you are very familiar with that. So you imagine you have a real object and you put a lot of sensors and you have a perfect representation of what happened in the real object. And you enter all this data in your model and you see exactly what happened in your real model. So that's a first type. The second one is the interaction of people with, let's say, object, or imagine a building. We can imagine people inside the building and you want to model everything what happened inside the building. But something quite different from the industrial aspect is health activities. We can imagine a person, you put some sensor inside the person and you can monitor the health of the person. And using a model, you can say if the person in a good health or dying. No, that's it's not. So the third one is a combination between 1 and 2. It's for very complex system like a platform, any kind of ship and plane and so on. So last one is what Gartner called an organization. So it's a digital twin of your organization, which is called DTO. And what's the definition Gartner proposed about the DTO? It's a dynamic software model which dedicated to your organization. But the point is to understand exactly how your organization is functioning, what's the current state, what's you want to change something in your organization, what happened? And using this model, you can imagine what will be the change. You can adjust some resource. We'll see that later. And of course, we can measure the customer value for values. So again, following a Gartner approach, it's like a journey. Imagine you want to develop a DTO. You start by your business model. You create the model of your organization. You measure or you assess the performance of your model and organization. And using BI software, you can get all the information from your model. And based on that, you act to do what you want. And we will give you some example of what we can do with a DTO to increase the value, not only the customer value, but the value with a big V of your organization.
Great, so I'll pick it up from there. So as Regis points out, it's a bit of a journey. And to support that journey for a DTO, there's a variety of technologies. So in Gartner's opinion right now, there's no one technology that meets kind of the full breadth of those building blocks. So they talk about enterprise architecture, enterprise business process analysis, business analytics. I'm sure you're very familiar, continuous intelligence. AI would probably focus in here at some point as well. And actually, I was surprised in the latest edition of this report, this market guide for DTO technologies, that they don't introduce AI, but process mining ties into that. And then BPA, or robotic process automation. But really, the key technologies as we see them are that middle section. So defining your business model, your strategy, and where you're going to go, the rubber really hits the road, and how you create the organization, how you measure the performance of that organization in achieving those strategic targets, and how you use that data to support better decision making. So again, I won't belabor this. I mean, we can give you the slides and so on, but I do want to point out a couple of key things on business operating model, which just talks about, looking at products and services, the outputs of an organization, understanding the resource that an organization has to do the work, the business processes to deliver those outputs. So that's the business operating model. As far as how do you measure that, KPIs become important, but also the ability to look at forecasting, future planning, using your business model, making those tweaks digitally around the future state of your business before you actually put it in place. There's real economies there. And then the use of that information, again, for better decision making, to say yay or nay, this is the path that we want to take. So we see these, particularly the ones here in green, as key components of a DTO solution, again, per the Gartner definition. So Regis and I, we actually had the opportunity, we sit on the board of the what's called Digital Twin Advisory Board, NGen, Next Generation. It's Canada's, I'll say administrator, but it's that makes it sound kind of trivial. Yeah, but basically they handle the funding for the advanced manufacturing supercluster funding that comes from the federal government on leading edge projects. And digital twin is one of those. So we adapted this to present, because really when we started working with them, they had not understood what a DTO was. So we kind of put this in their terms from a slide where, so strategy and business model, that is the business model, and then that gets executed. What we do, or what we believe, certainly in the tool that we'll show you here, is that can be articulated through some concepts, well-known concepts like lean value stream mapping. I'm sure all you're familiar with value streams, and activity-based planning. Has anybody heard of activity-based planning? Okay, so it's an evolved form of what would have been activity-based costing back in the day. So the combination of these two techniques provide that lens into understanding the business operating model. And then this is what the twinning loop. So the DTO model can look at what your value streams are, what your activity-based resource planning models are digitally, i.e. with a software tool. And then that gets populated with real data from the organization, both operational and financial data. So around your labor forces, around the equipment and your assets, how those are being used, consumed, and what the cost of those resources are. Remember that in a business, costs are driven by the resources. That's where the dollars sit. The processes and the outputs is how you consume resources, which means you're consuming costs. So if you buy into that operational view of costing, then you can understand the financials. So that's where the business performance measurement or management comes in as well. And once you have this model, then that turns data into results. So you can start looking at the utilization of your resource, the efficiencies by which you're consuming your resources, what's necessary to support your outputs, the cost, the profitability, the overall value proposition for the way you run your business in support of your customers' outputs, be they products or services. And then having that DTO model, the ability to run simulations, to do the future forecasting, to be able to tweak your data to see what the impact will be. Do you have constraints? Where are the bottlenecks that exist in your business? How are you going to overcome those? And what would the impact be on your costs and your profitability in doing so? So doing that all, again, digitally, as opposed to best guessing in the real world, which can be very expensive, could be right or wrong. So at least gives you the idea to basically support decision making. So that's the business operations intelligence piece. And then doing this, having tools that provide collaborative interaction. So management, mid-level, frontline production can understand and be singing off that same song sheet, understanding how the business works and what their role in that business is, which ultimately supports the business action. So there's kind of a couple of feedback loops that take place in that. So any questions on that? Okay.
Just a quick.
Oh, yeah, sir. Go ahead.
So like one of the previous slides showed kind of like the 5 kind of steps or phases or components of the kind of digital twin structure for an organization.
Right.
From that, like from what I gather, it's that more than anything, the digital twins, like virtual components, like the parts that are make it kind of digital, those are where the business, those feed into the business operations intelligence. Every other component is kind of like the
real world,
the input and output.
Yeah.
Stuff. So it's that phase. That
correct. Yeah, it's basically having this virtual representation that gives you better insights for decision making in the real world. Yeah, as opposed to what happens in a lot of businesses now. I mean, you know, there'll be data and they'll analyze data, and everybody will analyze it in a different fashion. They have their own lens by which they look at data. And that's quite often where a lot of waste takes place in organizations, of people not singing off that same song sheet, and decisions are made from data as opposed to new insights or results. So that's what the digital world offers. Thanks for that. So this technology that we're going to be showing that Crosby's used today, it's a Canadian product. So there's a firm in Ottawa that have developed that. And we've been using it for about 3 or 4 years now. I'll talk about a few applications. We'll dive into the Crosby's experience in a little more detail. But the product is called Collaborative Business Planning. So it's really the calculation, simulation, visualization engine that people can interact with at all levels in the organization. And it's built on a platform. How many people have heard of enterprise architecture? Business architecture. You guys cover any of that in your coursework? Okay, so enterprise architecture is a discrete type of business management solution that covers the whole enterprise with regard to policies, procedures. It's like, I liken it, my layman's view of it, it's a visual information management system. So it has some pretty cool visualized GUI interface that CBP takes advantage of. So it's a kind of and it's sold as like an add-on to the QualiWare platform. And then that product, they integrate certainly with Excel. Everybody's got to have an Excel connection these days, of course. both from a data point of view and from a results analysis point of view. So if you're an Excel guru, people are happy with that. But obviously now Power BI or any other BI. So these tools can output their new insights, the results into a format that any company can apply their own BI technology to support better information. And then this is all offered in Azure cloud hosting. So that's the kind of technology stack. And Regis had mentioned Quadrant, a lesser known IT advisory firm. They actually do a review of what they consider DTO technologies. Their interpretation of DTO, a little bit different than Gartner's, but fairly consistent. So as you can see, there's a lot of players in this field. And Qualiware, the one that CBP product is in, this leader quadrant. I mean, you've got the big guys like IBM and SAP, obviously play here well, Software AG, another large firm. And then you get very specialized solutions. I would certainly say Qualiware is one of those kind of mid-range tools that offer DTO capabilities. So this is a framework that Qualiware used to kind of describe what their platform offers. And again, if you had done any work on business architecture or enterprise architecture, you'd recognize the name John Zachman, who was kind of a pioneer in this field back in, say, at the 80s, back when I was in school here. And basically, this is what it covers in terms of strategy, process, application, information, all the components that make up an enterprise, both from a conceptual, logical, and operational. Again, purpose not to give you the whole education on enterprise architecture, but that's what enterprise architecture cuts across. Governance, risk, and compliance also plays into all of these facets, as does organizational modeling, and then obviously the ability to understand, evolve your business, transform your business, having a full understanding of your enterprise and so on. So what this CBP tool does, it goes after, really accentuates specific components of this framework. And those will be business rules. So how resources are used, the rate at which they're used, which products, which customers you're supporting, who's involved in that. So those are all covered in business rules. So being able to take those business rules and create a model that follows those rules. Very heavy focus on the whole process silo there, around developing business process models, optimizing, which is our theme for today, of course, and then tracking operational and financial flows through the business. And last but not least, the ability to kind of understand the organizational, both the organizational model and how you're structured and how your people work, both as resources and as deciders in that process. Not to say it doesn't touch upon some of the other facets here, but these would be I think, key strengths that augment the whole EA framework or business architecture framework. And then certainly on the bottom side, it's really the organizational modeling and the ability to communicate and understand at all levels in the organization. So some recent applications that we've been involved in with DTO using this CBP technology. Probably our latest work was with Passport Canada. You might have heard they had a little problem last year with regard to throughput and efficiency and backlogs. I'm not hoping anybody was caught up in that, probably were. So we worked with actually a firm, some of you probably familiar with Barrington Consulting, just down the street, who employ a lot of IEs from this program, I think. So I worked with Robert Newcomb actually on that project. So we did some value stream, we did some process modeling, we did a lot of efficiency measurement, strategic planning with them and so on. I won't take full credit for them getting out of the problem that they were in, but in some small way we helped in that. We've also done a lot of work with Veterans Affairs Canada in Charlottetown. One of their programs, disability benefit program, has been chronically problematic for them with regard to turnaround times and meeting service standards. So we just did some DTO modeling there. An earlier one was with Nova Scotia Crown Lending here in the province. So that's the funding agency for loans for fishers and farmers, providing loans to stimulate that economy. We've done some work in healthcare. Again, we did that again with Barrington in the area of long-term care. looking at resource planning and long-term care, and another chronic shortage issue there with RNs, LPNs, and CCAs. We also did some work on home care nursing with Nova Scotia Health, looking at location of nursing and travel around the province to support people staying in their homes and not getting into long-term care. So that was quite interesting. Another local story, transportation, Marine Atlantic, if you're ever gone across Newfoundland on the boat. We did some modeling of maintenance management around those ships and vessels, so they could improve their uptime and availability. And then in manufacturing, we're going to do a deep dive into manufacturing, particularly with the work at Crosby's, but we've done a lot of work now recently in the dairy industry and cheese and poutine cheese specifically. So with the company in Quebec. So it doesn't, I mean, a lot of people think digital twin, oh, that's got to be manufacturing. It can definitely be service industry, it can be government service, public. It's all around being able to model your business and your business processes and how those resources. So business is business to some degree. If you think about it in the elemental forms of resource, activities, and outputs. And digital twin is really a simulation of all that. So, okay, so let's jump into Crosby's. Actually, was originally a Nova Scotia company, started in Yarmouth, and about 15 or 20 years afterwards, they decided they needed a better port, so they moved it over to St. John, New Brunswick, where they've been since, what would that be, 1890 something. So 5 generations still in the family, run by the Crosby brothers. And they're more than just molasses. People think, oh, molasses. Well, they've actually rebranded. They're now called Crosby Foods because the bigger part of their business is third-party packaging. So, for example, the Jell-O products, the no-name Jell-O products you get at Sobeys or Best Buy or whatever, they produce all of Nestle Canada's hot chocolate, Nestle's iced tea. So they do the formulation and packaging lines and basically production for that. So, but still, kind of small, medium-sized manufacturing business per se. So they took an approach, this probably going back 2 years now, I guess. Senior leadership actually was the CFO. We do a lot of training with CPA Canada, CPA Nova Scotia, like in the accounting world, because it's a costing tool as well. So he'd come to a workshop and just right place, right time. Hey, we need better costing. So we started an engagement with them. They put and this is very typical of how a project would roll out. So basically create a multifunctional team. So you need people that understand the process out of the production area. If your company has a continuous improvement, kind of a lean focus, great to have them involved if they're not part of production indeed. And then certainly finance, because we do want to look at costing and budgeting with that. So they got some training both on methodology and on the technology, that CBP product that I talked about. And they took a phased approach. So they started small. Within about an 8-week time, they did a couple of production lines on what's called their drink crystals. And then they expanded that to their whole dry product line, which included the Nestle hot chocolate, which is a separate area, because it's a milk allergen, so it had a separate sanitation and hygiene considerations. And then they moved that to the wet, and then actually subsequently 4 phases, they did their bulk handling. So they have a large bulk handling facility on West St. John with big tanks that you, if you've ever been to St. John, you wouldn't miss them. So that was kind of a little bit about the approach. I thought it might be interesting to see kind of exactly take this concept of real versus digital. So I got a little video here. We'll show one of their production lines, which is for drink crystals, their own branded drink crystals. So what you'll see in this video, you'll see, things around the bill of materials. So different components that go into the product itself. You'll see some direct activities. What you won't see, but we will talk about, are the indirect activities, and sometimes those are the killers. The downtimes, the breakdowns, the changeovers, the setups. Those are the things that steal capacity away from the line, lead to inefficiencies and higher costs. I'm sure that's probably been covered in many courses that your professors have provided. So I'll just turn the sound off. I'll just give you kind of a quick guided tour. So this is what's called the Bartelt 4. Bartelt's a German manufacturing, fairly old piece of equipment. It's probably been around about 30 years. This is what's called the web roll, where all the pouches are contained, and then they're formed into kind of this white label kind of they're coded, obviously, date stamp, so every packet has the product. They're cut and they're heat sealed on the sides, and then they're open. So the ingredients flow. They have a mezzanine where they do all the blending, and those go in a controlled fashion. Obviously, they're heat sealed at the top and then put on this conveyor, and then they go into what's called the poly bagger. So you can see the poly up here. That forms a plastic bag, and then you see this is a collector that takes 3 pouches. We'll insert those in the poly bag, seal the bag, and they come on the other side. And from here on, it gets pretty manual. So they come in an accumulator table here, and some poor bloke has to come along and stick them in the case by hand, and hope that he can do it fast enough. Don't know if there's probably anybody of my age that would remember the Lucille ball with the the beer things, but they come out here, they go to a taper, another coder, and again, another manual process. They sit at the end there, and then they're hand stacked onto a pallet. Ultimately would be shrink wrapped and then sent into to the warehouse. So what we thought this was just to show you what that means in a digital format with this modeling tool and what they did on the modeling. First thing we'll start with is the value stream. So these little color code here, just to give you a little assist on that. So anything labor versus equipment or facility, bill of materials, you'll see some of those activities. Those are the kind of the building blocks of processes. You can highlight those if it's a non-value added, something you want to minimize or reduce or ideally eliminate. We'll highlight that. And we can also look at total cost of quality. And I've just identified 2 components, one for good quality, i.e. prevention. So don't have appraisal in this one, and one of poor quality, which is internal. Although external product failures are obviously more expensive than internal, but we're just going to talk about the internal. So you saw the pouch filling, and then you saw it going to the poly bagging, and then you saw the case packing and the palletizing. So the data, and again, how many people have done value streams? Most.
It's the basics.
Most.
Basics of
Who taught value streams? Who taught value streams? So this is some of the data you may recognize. So lead times, PT processing times, percent complete and accurate. How often is that done completely? Which group is responsible for it? And then how many staff that you have, because with that data, you can actually calculate your timeline, and you can get some of your lean value stream parameters. So your total processing time, your value added ratios, which are an indication of how much processing time versus total time. You've got your roll throughput yield, which is the multiple of all your kind of percent complete and accurate. So it's basically an indication of what percentage of the time do you get one product right through the line complete, right the first time, and so on. So again, we'll see this in the software too, but I thought it easier to kind of explain. Then we can also look at some of these other non-value added activities. So breakdowns being a good example of an asset failure rate. So these components will have an impact on your overall average wait times. So they're adding time to your average process throughput. So obviously things that you want to minimize. I didn't point out here the tool will calculate for you based on the volumes of these for any particular time period. These models, DTO models, are typically built over a time period. Could be a month, could be a quarter, could be a shift, and you decide what time period this will be modeled for, and then the data that you use to populate that model comes from that time period selection. So this tells you basically how much staff you need. And obviously to look at this and say, that's a lot of people dealing with breakdowns. So what can we do to minimize breakdowns? What can we do to minimize changeovers? Can we do longer runs? What would the impact of that be? And then we've got a lot of other non-value added, like rework. Okay, so in that process, you saw that pouch filling process. It's an older piece of equipment, so occasionally there's jams, the web doesn't form correctly, so there's waste. There's some recycle maybe of materials depending on where it's caught and so on. Same thing with that bagger. There's jams in the bagger that they're going to lose product potentially, certainly lose the bag. So that's an extra labor and takes away from the efficiency of the overall. So that's kind of what you see as far as the value stream. The activity-based planning, what that is basically it's a resource optimization. So if we look at the resources necessary to feed that line, I didn't point them out in the video. You might have seen a young lady in behind. She was the operator. And you definitely saw the poor fellow at the end doing his case packing. So operators and packers, we can actually model over time if that's a component that needs to be understood in the process because it adds capacity, but it adds capacity typically at a higher cost. So we might want to be able to do simulations around that. There's a bit of symbology here. So these little round pieces, they're called connectors, and it just allows you to avoid having a big complicated spaghetti network when you move from one item to where it's consumed. So anywhere you see L2OP means it's a line 2 operator that's involved in that particular activity. Moving down on the asset base, you have the actual line itself. So the line it takes up as a footprint in the plant. So there'll be some plant related costs, the insurance, depreciation, utilities, so on. And then how is that line used? Most of it, hopefully, is used for running product. And when you run product, that's really when the machine is requiring electricity. So when it's down for cleaning or if it's down for preventive maintenance, typically it's not going to require electricity. So you want to bring in the resources at the appropriate point of where it's being consumed and so on. There are 2 other activities. So because it's a food product, hygiene, sanitation is important. So at the end of the shift, typically there's a cleaning cycle that takes place after every shift. There's a deep clean that takes place every week. And you can see, so here we have that L2O. We also have the packer getting involved in that cleaning, but it also takes the line out of commission. So we want to be able to track the amount of time that cleaning takes because that impacts our overall availability. Same thing, preventive maintenance, not necessarily done by the operators and the packers, but done by the maintenance folks. And then if you want to break it down, and again, this is an optional, depends on what your questions you're trying to answer are. In this case, the bagger was a high maintenance product. So they said, let's isolate that, even though it's a component of line 2, let's isolate on that because it's got some unique requirements with regard to cleaning, with regard to preventive maintenance, with regard to the electrical consumption on that particular component. So we can actually simulate that. So that's kind of very high level, some of the resources. And then if we look at where those resources are used, so here we are back to our 4-step process, and we look at the resources. So you can see we've got line 2 operators coming into the pouch filling. They're overseeing the filling operation, and the packer at the end, we saw this fellow doing this, but they oversee the polybagger and the palletizing as well. We see some bill of materials coming in, so the actual cases, the poly bags, the web rolls where the pouches are created. We see some support indirect activities like the web roll change. So when a web roll in this particular piece of equipment, it's not done kind of online, not spliced in, it's actually a downtime to remount the web and splice it in and then restart the machine. So there's downtime associated with that web roll. So these are the activities, or sorry, resources to support that. And then down at the bottom, what drives that whole process is the demand for this particular generic product. I'm going to call it level 2A. So I'm going to show you the model. It's all illustrative data. It's not Crosby data, but it's based on the Crosby experience. So here's where you have rework, both at the pouch, misformed pouches, or at the bags. And those items basically say, hey, I've got to create the pouch, including making the changes on the web roll, so that when I start looking at things like the cost of pouch rework, it's not just the operator time to deal with the bad pouch, but it's all the costs above to actually create the pouch that is wasted. So it really magnifies the importance of rework and that's quite often new insights for production people. We have the other ones, the breakdowns, the changeovers and so on. I'll be able to show you this actually in the model. So let me do that. That's my cue to go to the actual model. So let me get out of here and let's fire this up. So this is that product I mentioned, collaborative business planning. So again, you see, I just took screenshots in the slide and so on. So if I look at some of these resources in a little more detail, you'll see there's some little green V's around. Those are variables that we can use in multiple places in the model to give us simulation flexibility. So for example, we have $25 is the hourly rate they're paying operators. We only have one operator. It's a monthly model. But that monthly model, there are 40 shifts that are run in that time period. We have overtime. So in this case, we're saying we have about 20 hours of overtime that would run that month, and that would be able to handle the peaks and the valleys. So even though the utilization of a resource on the average for a month, let's say, is 85 or 90%, they could still need overtime. If there was a demand product, there's a shipment that needed to be done, they may have to push that through that day and run overtime that particular day. If I look in this a little deeper, so I'm going to open up this object. So this is the production. So you get a little bit of information, that you can detail. So again, people can see this. This can actually be published onto the web too, and people can understand what the context of the model that put this together. But we start to look at some costs. So I can put my production wages, my hourly wages, and this is where I would use these variables. So how many operators, how many shifts? If I open this formula up, there's a little formula editor here. It says, okay, so the number of operators times the number of shifts times the number of paid hours per shift. So these are 12-hour shifts. And then the hourly rate that would give you that information. So it's total of $12,000. The capacity of that labor group is the operators times the number of shifts times the practical hours. So even though they're paid for 12 hours, they're probably only getting 10 and a half hours of work if they have the breaks and downtime and lunch and things like that. So you want to make sure you're looking at practical capacity. So now when we'll see this, when we flex this, if I flex something, I can flex the operational information, i.e. capacity, and I can flex the cost impact of that change in one go. That becomes very important. If I look at where these where they're used, if I go to the links, I can actually see what's coming in, which is called my inflow, and what's going out. So these are all the places that are used. This model is currently uncalculated, so everything shows as 0, and it says recalculate here. We'll do that shortly. So just to give you a flavor, and I'd be able to open up any of these activities. If I go down to the process area and I look at let's look at pouch bill, for example, and I can open up and I can see, okay, here are the components coming in. So there's my operator coming in. This actually tells me the consumption rate of how much time the operator, this is in terms of hours. So labor hours, 0.008. What does that mean? 0.008 hours per case. The units of measure on this are per case. Okay, so you've got to be careful when you're collecting and putting your data in that it's relevant to the units of measure by which you modeled. And that's certainly a decision that's made. Typically, you'll model based on the way the business thinks about its throughputs and its efficiencies and so on. And then down here at the bottom, we've got this product. This is just one product line, an illustration. So there's a bigger model in behind this, but for today's purposes, some of the other drivers of that, basically the scenario, they've got 3 different customers, customer 1, 2, and 3, that buy product L2A at different rates. So the more volume you buy, typically the lower price are going to be offered from the company. And then we just summarized some of the production variables here. So our production rate, our average run size, pack configurations, how many pouches per bag, how many bags per, so these are all used in the determination of resource consideration. So what you have now are variables that allow you to flex the business in these, instead of hunting around for particular pieces of data, you can bring the relevant data that you want to maintain to the surface. So if I calculate this model now, I hit the little calculate button. So basically what this has done is it's taken the need for 18,000 cases, and push that up. And based on things like my rework rate. So my rework rate on pouches is about 3%. And as a result of that, I'm going to have to rework about 53,000 pouches this month. That's a lot of rework, a lot of costs there. Now, we're not seeing the cost yet. I've got to do something to get those. But it's basically saying to create 18,000 cases of end product, I've got to generate 18,557 cases because I've got to deal with this rework. Same thing over with the bag rework. I'm going to have to create additional product to handle the rejections that I get in the process. And then that flows up through the model. And then if I continue up to back to my resource page, now I can start to look at how well am I using my resources. So I've got how well my line is being used, 75%. The bagger's a little less than that. There's a difference there with regard to the maintenance and the end of the shift cleaning that causes that difference. And now I can see the utilization of my different labor groups. So that flow, the calculation is from the bottom up. And then if I hit the calculate button again, I actually will layer in now the financials. So the dollars actually flow from the top down. Remember what I said, that resources where your dollars are. So if we look at our operator here and what we had as far as our costs, 12,000 and 2,400 in what we'll call direct costs. There are some indirect costs. If I look at my links, these are costs that are flowing in. So there's a supervisor and there's some overtime that comes in. And now I can look at where my operational flows and my costs go. So the operator, the biggest point of time is obviously in the pouch filling, but 20% of their time is spent on pouch rework. So you can anticipate this pouch rework is a very expensive, non-value added activity. We can get more details on that as we move down. So if I go down, let's actually look at that. So if I go down to pouch rework, you see now on the model itself, you'll actually have some operational flows, how much is coming from the driver from below, and you see how much the actual accumulated cost at that point of the model is. And if you drill into the details, so this says about $8,400 is the cost of pouch rework this month. That's pure non-value add. That's basically going right to the bottom line negatively at a cost of 16 cents. And if I drill into that, I can start to get some better insights around what are the drivers of that. Because if I look at what's called PMO, so these are the primary modeling objects, any component in your DTO model, it'll tell me how much winds up at this point in the model, the flow, what percentage of the total that is, and what the relevant cost is. And for those financial folks, you can actually get a P&L basically because it tracks all of the cost accounts as they trickle back down through the model as they're split and recombined based on the way resources are being used and the activities necessary to support them, both indirect and direct activities. So then at the end of the day, if we look at the result here, we say product L2A, it's losing money, about 55 cents a case. The average price is $14.56 per case. So we're losing, you know, what's that, 5%. If I go up at the top here, here's a little summary. So overall, we're losing about $8,000. So let's say sales and marketing comes to us and said, oh, well, we can get more volume because we've got more capacity here. We're only at 85, but 75 to 80 on labor. We've got more capacity on our piece of equipment. So let's say they go to customer three, I'll give you 50% more volume, but I expect another $1 a case discount. What would the impact of that be? So we can actually simulate that. We put then 15,000. And let's change the price from 14 to 13. And you'll notice as soon as I make any data change in my model, everything disappears because the whole thing needs to be recalculated. It's very dynamic. So if I recalculate this, it comes up and it says, oh, you can't do that. You don't have the resources to do that. And if you can zoom in, it'll highlight which resources are problematic. In this case, that we don't have enough operator time. So now we have a business decision. No financials can be created until we resolve the operational constraint. And that's really important. If you're a bunch of accountants, you'd be all squirming in your seat here now because, oh no, we use standard costing. And we just extrapolate that and that's wrong. Because you've got to resolve that constraint. So, okay, so you're all IEs in this room. What are some of the things you would do if you were running this production line? What could we do to resolve this operational constraint? Suggestions? Get a few ideas out.
I don't like overtime, but have you included overtime in the
Yep.
operators?
Yep, right there. That's an option. So, okay, thank you.
I don't like.
Thank you for taking a lead. Great. So if I look at, I've got 465 hours I need. I've only got 440. So I could work another 25 hours of overtime and resolve that constraint at a premium,
Of course.
but that may be worth it. We could try that. Yes.
You could reduce overtime and purchase another operator.
Okay, so we could, these are all what I call brute force answers. I'm hoping more from this class.
Will the model do some line balancing?
Not automatically. We'll come back to that when we start talking about AI. So yes, we could add more capacity by hiring another person. We're running at 100%. If we just added another person, we'd probably be down to 53, which would be kind of inefficient. So
You said that rework is taking up quite a bit of resource.
here we go.
So if you address that in itself, you might be able to
Right.
rerun it again, assuming that you fix the rework.
Yeah, okay, so rework would be, one, can we optimize rework? Let me go to the process side where you guys can focus in here.
Yeah, did you determine the bottleneck, like the production line, the bottleneck?
Yeah, the bottleneck is people. Right now, the utilization of our labor, of our line is 94%. So the line can handle this volume. We just don't have enough people. Okay. What about shifts? We could do that, right? We could add another shift. That might be the effect if we did that. So let's just say we took the shifts up 44. What this is gonna do now, it's gonna multiply, add 4 more shifts of operator, add 4 more shifts of packers as well. And there's 2 of them. So the cost impact, if I run that scenario, so we're going in the right direction. We're only losing $1,000 now. Okay, so that would be a viable, potentially, better than it was, but maybe not as good as it could be. So let's follow up on that comment about rework and process efficiency. So if we look at some of these process components, i.e. production speed, that's a big driver. The run size, which is going to impact your changeovers, which is downtime. Your breakdowns, why are you getting breakdowns? So let's say we get the little multifunctional team together, including maintenance, and they say, well, yeah, this line's getting old. We saw it. It breaks down. We need to do more preventive maintenance. And if we do more preventive maintenance, they say we can probably cut down on the breakdown rate and we can speed up the amount of time that we need because most of the equipment's going to be performing better and I only need to work on this one. So we could run that as a scenario. So let's do that as an example. So I've got right now, they're running 3 PMs a month. So let's say they move that to 4. So they do 2, they do 3, we're going to go to 4 per month. And I think these are 6-hour PMs and these are 3-hour PMs. And we could actually look at the impact of that, but we want to see the benefit. It's not going to change much. It's not probably going to add cost because now we get more maintenance costs associated with this. But what would the potential benefit be? So they say, well, we could increase production speed, let's say by 10%. So I'm going to go to 66 cases per hour. Because I have this higher volume of L2A, I could actually increase my run size. So let's say I go from 450 to, I don't know, we won't double it. Let's say 800. My changeovers, we can leave those the same. They're still going to take the same time to change over, but the breakdown rate, so if we can cut this from 3 to 1.5, we'll just cut that in half. And we'll take our breakdown time because now they don't have to be down as long. Let's say we could take that down to 30 minutes. So this is what maintenance tells us that they think better PMs would do for us. Production comes and said, well, geez, if you're going to fix that problem, I'm not going to get as many jams in my pouches. So maybe I could reduce my rework rate from 3 to, let's say, we'll cut that in half, just as an illustration. And I'm going to cut my bag rework by 50% as well. So take it down to 1. So I run a bunch of different ideas around this concept of not having better preventive maintenance. What would the impact of that be? So I run that model. And okay, now I'm in the black. This is good. But we're not quite finished, are we? So we've got to look at now our utilization. So we're really underutilizing our labor now. Remember, we took it up to 44 shifts. We definitely want to go back to 40. In fact, we could probably go a little further. We don't need as many shifts. So if I could take that down, let's say 34, I'll see if that works. Take it down to 34 shifts. Okay, it's no broken constraints. I'm back in the mid 80s, high 80s. So again, I probably don't want to go right to 99%. That's false economy. So I want to kind of keep it at the same level. Unless I'm going to make
it around.
Yeah, exactly. And now let's do the financials. And yeah, so now I'm making so I've just generated $20,000 of profit, even though I've had higher costs of maintenance. But now my production rate, my better utilization of my equipment, reduced waste, reduced costs of bill of materials, all of that. And of course, you can, all this information you can analyze and do the, yes.
With regards to maintenance and stuff, is there a way to kind of like tie in your maintenance decisions to kind of cascade into those other things? Or are you kind of having to like get around the table with a bunch of people and kind of like hammer out what those numbers would turn?
No, well, I think we got a maintenance expert right here that could do some Python and some things to actually simulate what the benefits would be, and then you could bring that into a model, or you can model in another fashion. I mean, this is not the only DTO modeling tool, of course, right? So yeah, you can have external interpretations that could be then fed into the model. Sure.
Mhm.
Yeah. So anyways, hopefully that just gives you a feel. All of this information can be exported. There's a whole rich set of data integration and export and things like that. You can pump that out into Power BI. And this is what Crosby's did when they started looking at the different types of non-value added activities in the magnitude. These are again fake data that, you know, you can see what the target areas would be and so on. So one of those, and I'll just go back to the slide where to finish up. So to finish the Crosby story here. So what they found after they did this DTO modeling and they were able to understand how to better optimize in the Nestle area, they had, I don't know if you've ever bought the little 7-pack of Nestle hot chocolate with the 3 different flavors in it. 7 and 3 are not good numbers in manufacturing typically. So they had actually one line. They had twin lines making two flavors at the same time, and then they switch it over, make 2 flavors, and then they've got this other extra that they got to make. So one line actually sits idle. And they all knew it was a bad thing, but now they could understand what the cost of that was. So they made some changes in the way they kind of did some Kanban kind of thinking and just-in-time production and so on. They wound up saving about 18 12-hour shifts a year, which are significant dollars on a 9-person shift. They did some ROI. They actually added in some robotics. So not in the line that we saw, but in another line, they actually have a robot now actually doing case packing. So that's a potential to move that to certainly other lines. They allowed them, right now, they're exploring other third-party manufacturing contracts. So now they know how to tie in the capacity and the planning and all of that to get better costing so they can be a little more efficient in the contract negotiations. They use it for annual budgeting and planning. And probably, you know, I think they would agree with me, but one of the benefits I saw was the fact that the executive can sit around and fully understand how the business works, instead of different people's interpretation. That includes sales and marketing and finance and operations all in one go. So in summary, really what DTO models do, regardless of their CVP or others, they take a business operating model, which we've described as your resources, your processes, your outputs, create this structure that then gets populated with organizational data, be that operational data, ERP systems, labor data, payroll data, financial information out of your GL structure, populated at the appropriate place where these resources are consumed, and then through calculation be able to get better view on how the business works, to be able to run simulations, understand where the bottlenecks constraint exists in the system, and ultimately get better information for decision making. Dashboards are a great way to do that. So final slide, we always like to say that DTO models, they really do support a multifunctional. So I'll let Regis talk about the strategic values here.
Yeah, probably something to add to the presentation here. It's just one line. So imagine exactly the same model with 100 line. So human is not able, the brain human is not able to manage and to see exactly what happened in a so complex organization. So I think that's one of the benefits of this tool, is to really understand what could be a complex organization. So strategy. When we speak about strategy is how could you optimize your resource. So for example, if you want to change from manual activity to something more automatic, you could decide to buy a robot. So what happened? So okay, that's a new equipment. We could be here kind of investment. You want to add a new line. What happened? You want to tell to your customer, we can do that for you, and so on. So it's all this strategic insight we can provide with DTO.
Yeah, the real value is, again, having that one song sheet that can meet all of these different insights that can be provided. On the operational side, obviously, we showed this one on demand planning and the impact, tying it out to the resources, understanding how your utilizations, obviously applying lean principles. So lean and value stream, I'm going to probably offend some people here if you're Lean Six Sigma opponents, but value streams are really great at understanding process flow. They're crap at understanding resource costing, capacity components of the lean, most of the lean tools that I've seen anyways. So there's quite often there's a little bit of back of the envelope calculations that go along with value streams. So this is a little bit more integrated and allows lean experts to work with that. And that's what we've done with Barrington in many cases. And then certainly because it brings in the dollars, getting the costing, the budgeting, looking at pricing. Where should we be on pricing? What can we afford? Can we actually lower our price and be more profitable? Sometimes the answer is definitely yes, depending on your utilization, how you're deploying your fixed resources particularly. And then profitability analysis, not just on your product line, but on your customers. Just think again on DTO organizational, your customers, yes, they may buy your product, but they also need support. There's warranty situations. There's the sales and marketing, the relationship management, all of that. You can model all of the people that touch your customer, not just the ones that are buying your product, and actually see what the full cost and the full profitability of that customer is, which gives you some insights on what type of customers do you want to actually go after. Obviously, the ones that drive more to the bottom line. So
I saw a talk on digital twin recently at an academic conference, and there are lots of consistencies, and it's really nice to see a real application. But one thing they talked a lot about was real-time synchronization, right? So you have the real-time data and the real-time model. And to me, that was the piece that separated this whole concept from just a simulation that was very comprehensive. I'm curious about that piece in your work.
Yeah, I mean, that's a good question, because that's the engine, the cluster funding for companies. I mean, that's the question they ask. And we produce a slide to explain what does it mean real time for us. For an organization, what exactly is real time? Are you changing your assembly line each hour, each month, or each year? So I think we have to adapt the word real time to exactly the process. So for example, here, I don't know, we are speaking about shift. So it's a question of, let's say, day. From some variables, you could have some real time, but for big equipment, it will be a real time, but not exactly the same time scale. So I think we have to adapt. We are not speaking here about a DT with a twinning, a real-time twinning to the microsecond. It's useless here, and you have to adapt exactly like Shannon said. I don't know if you're familiar with Shannon. No, so you adapt your frequency the frequency of your data to the process. That's a keyword.
Yeah, we call it decision time data. So as Regis says, I mean, once you create these models, like what I just showed there, you could do a time slice down to a shift. You could take it to a week. You could take, so what decisions are you making within the shift versus within your weekly planning production schedule versus your quarterly budgeting? Same model supplied with different data. The longer the time period, the more you're normalizing and flattening the ups and downs. But sometimes those ups and downs are important. Our discussion about overtime, for example. So yes, we can take, I mean, in Crosby's example, they use SysPro as their ERP system, which is kind of a mid-range and specialized in manufacturing. So they are extracting data from that to feed that model, but they do that on a monthly basis because that's the frequency at which decisions are made on production scheduling. So